Hello and welcome everyone to this live session in the NPTEL course for Secure Systems Engineering. We are now in the completed the sixth week, and I hope you are actually enjoying the course. So this course, as such, is a very unique course which looks very deep into programs and into systems to actually look at what causes vulnerabilities in the system and how an attacker could actually utilize this vulnerability to make or design malware. So we focused a lot on the Linux operating systems, although almost like 90% of whatever we have actually discussed will fit directly into a Windows OS. So if you've been able to follow this course closely and you're able to run the various demonstrations that we have actually shipped with this particular course, it will not be too difficult for you to actually transition to the Linux from Linux operating system to the Windows operating system. Also, towards the mid of the course, we have actually looked at other aspects. We have seen how a system can be designed to be more secure. We looked at very modern things or very recent things like trusted execution environments, the method of least privileges, access control mechanisms, and so on. So, one or multiple of these mechanisms are incorporated into modern system design in order to make it more secure. Towards the end of the course, uh, especially in the sixth, seventh, and eighth weeks, we'll be looking at hardware security. So, we'll be shifting our focus from the software and moving towards the hardware. We'll not go into too much of detail because point one, this requires a totally different expertise. But as a security engineer, it's important for you to understand that an attacker could use any entry target into the system. If he is not able to enter through a software vulnerability, he would then target the hardware and use any potential vulnerability in the hardware to enter or exploit your system. Okay, so yeah, in the seventh and eighth weeks, we'll be looking at some side channel attacks. We'll be looking at modern attacks like the Meltdown Spectre and other micro-architectural attacks. We'll be in particular running a cache timing attack. We'll be sharing the code with you, and hopefully you'll be able to actually replicate this codes in your own laptops and systems using the virtual machine that we have actually shared with you. Okay, so I have a couple of questions which we have actually got so far. So we will be going through some of them. The first question is by Sri Venkata Krishnan. Is there any internship available after the course? So yeah, to let you know that we are always open for to internships, especially if you were able, in particular, if you're able to actually, you were able to follow all the demonstrations that we have shown, able to actually run some of the, or break some of the examples that we actually put up on our Bitbucket website, some of the challenges. You're able to do well in the exam and taken this course very seriously. Please send me a mail. So we'll definitely get back to you if we have an opportunity for an internship. So we are also looking for students who are interested in doing projects or master's level in this particular area. So our area, of course, is to not just to attack systems, but more importantly to be able to detect attacks and also build systems which are protected against such kind of cyber attacks. So our the systems that we design are protected not just in the hardware, but also at the operating system and in the applications, so that they are more resistant to cyber attacks. So we have a couple of projects which are currently going, which we are currently working on, which uh, try to evaluate and detect malware and how they function. Uh, Try to actually build systems with improved security, and also try to actually design systems which are resistant against these new forms of microarchitectural attacks like the Meltdown and Spectre. So yeah, so I'm always open to s- students who are interested to do internships. Yeah, provided that you have already taken this course very seriously and uh, been able to complete the challenges and the demonstrations or follow the demonstrations and so on. Okay, so uh, so another question from Deepak Negi. So the question is about more examples about various vulnerabilities covered up till now, from the basic to advanced. Okay, so I would like to deal with this in a different way. So if you actually look at the vulnerability database, which is available online, you will see that there are like loads of different vulnerabilities and exploits that are popping up on a day-to-day basis. So this is a very growing and very interesting field. And what makes it difficult to actually evaluate specific vulnerabilities or specific exploits is the fact that modern day malware would not be just using a single vulnerability. For example, we looked at this malware called stage fright, and we looked at it with respect to the integer overflow vulnerabilities. But in fact, what stage fright does is that it combines various different vulnerabilities. It actually combines integer overflow with a heap exploit, with something that breaks ASLR and so on, right? And therefore, modern day malware are extremely complicated and extremely complex, and rightly they have to be so because side by side as malware evolve, antivirus solutions are also evolving at a much uh, at a quite a fast rate, and therefore, if a malware, if somebody wants to actually design a new malware, there's a lot more effort that actually goes on so that it becomes undetectable by uh, modern day antivirus software. Okay, so there's a question. There's a very interesting question by Ranjit MR. How do attackers spread their malware? Now, again, I'm sure you must have already seen many instances of this. There have been like emails, you receive spam emails, you receive pop-up windows, and so on, where malware, where emails would actually force you to click on a link, as we've discussed, and this could lead to uh, the transmission of malware from one system to another. Once it, for example, infects one system, uh, then the malware would read your entire read your entire address book, and then send the same email to everybody else. So, besides this, there are various other ways by which malware can spread. One very popular way, and I would like to refer you to this very recent malware known as Mirai. So, Mirai is a malware which actually targets IoT devices. I could share this. I could share the link with you at a later time, maybe through the discussion forum. So Mirai, for example, would randomly generate IP addresses and try to connect to those IP addresses, and through a telnet protocol. And if they are allowed to actually make a connection or find a device which actually responds to a telnet to the telnet request, they try to guess the username and the password. So it's quite surprising to actually note that Mirai just has a database of 62 username and passwords. Or at least some most variants of Mirai just have a dictionary of 62 different username and passwords, and they would try each username and the corresponding password, and they have been quite successful that to penetrate into many IoT devices with just by trying this method. Um, okay. Yeah, another very interesting question is by Mohammed Ansari. Okay, so his question was on 64-bit architectures and how these attacks are uh, uh, are there any attacks and vulnerabilities. So this is something I should have brought up in the videos. All everything that we have done so far is on 32-bit platforms. The reason we took 32-bit platforms is that it's a bit more easier to manage. The addresses are small, and for a learning perspective, it's much more amenable to learning about learning various vulnerabilities and so on. However, all that we have studied so far, uh, whether buffer overflows, heap exploit, integer vulnerabilities, and so on, are directly applicable to 64-bit platforms as well. The only thing that you'd see different is that the addresses are now larger. There's a much larger address range, and besides this, there is nothing more that is very significant that is significantly different from the 32-bit platform that we have actually looked at. Okay, and other question from Ganesh Nalamotu. So Ganesh asks about. Uh, so his question reads as follows: in what way can we secure our systems from theft, and in what way we can get back and track our electronic gadgets when they get lost? So yeah, this is an interesting question for me because it also shows that there is huge amounts of job opportunities with such kind of um, things. It's not very easy to actually design systems which are completely secure, and especially in these days, given that there is a growing threat of information security, growing number of malwares that are being generated. Therefore, um, a lot of companies are actually looking out for people who can actually secure their databases, secure their websites, and secure their entire IPs. And I wouldn't say that I'm not able to answer this question completely because uh, it's probably a huge research challenge to actually develop systems which are not just which are completely secure. This being said, the best way to actually, but totally impractical way of securing a system is to completely disconnect this system or your system from the rest of the world, completely disconnect it uh, from the internet, disconnect all kinds of cables, connectivity, and so on. No USB sticks and so on, and then your system is secure. So this was what we actually looked at in the first class. But yeah, and you can guarantee that the system is actually secure. On the other hand, if you make certain assumptions, you let internet uh, work on your system, you get connected and so on, and then you see that there is uh, a lot more things you need to do to actually achieve security. So take the example of the banks. Till a few years back, the only way you could actually um, withdraw money from a bank is that you go to a bank, write a check or something, and get out the money. And therefore, you see that the only way that the money can be stolen is somebody physically enters or breaks into the bank. Now, on the other hand, things have become more flexible. You have various banking websites, you have credit cards and debit cards, and a result of that is there is also a great security threat. The threat for security has also escalated much more larger, many more times with the current things. So what you see over here is um, the more opportunities you give, the more uh, things you actually do to more uh, support you give for users, more user friendly your particular application is or your particular organization is, the greater the threat to security. So designing a secure system is often a compromise between what are the features that you want to support versus what are the security guarantees that you want to achieve in your system. Okay, so a final question from uh, Robert. Um, Robert asks about courses and books that can be used in this course. Unfortunately, there are no books which can cover all of these aspects. There are certain books or a lot of free material online which you can use, but as such, there is not a single book which would cover all of these topics. So the best way is to use this particular course as your starting point, and then from this use the various internet resources. You could look up the various certification or like ethical hacking examinations, which you would actually find it much more easy once you have actually done this course. Yeah, so there are also so there are also certain questions. Show some demonstration. Okay, so there are a lot of questions which are like there's an overlap with the question papers and the assignments that we have done, and that is part of the course, and therefore we cannot answer those questions. Uh, there are some relevant questions, however, like and some questions like how does ASLR prevent heap exploits? So these questions have been answered in the following questions. Okay, or it was in the assignment. Okay, so here is one question by who by Swati Dekha, who asks where are puffs used nowadays. So puffs, as we know, as we've seen in the lecture, are physically uncontrollable functions, and they are used. They essentially are used to identify uniquely a particular device. Um, Now, puffs are a very modern technology. It's the first puff was in the early 2000s, and the first puffs were very impractical and therefore not used at all. Uh, right up to like 2012 or 2013, puffs were more in the research community. It is now getting into products. For example, you have NXP who is starting to use puff in their microcontrollers, especially the microcontrollers used for IoT devices. So you would now be able to authenticate an IoT device using a puff, provided the puff is from NXP. Now, if you used FPGAs, the Xilinx and Altera FPGAs, what we know for certain is that Xilinx is now going to introduce puffs in their FPGA. So you could use your puff to authenticate your FPGA, and it opens up various things such as validation of an IP. You create trusted third parties and so on. Uh, so another question from Krishnendu Das. In information security, which part is more information is most important? So if I just look at information security from a bird's eye view, so it comprises of I would say three huge components. One is the security within your computer system. One is the security outside your computer system, that is the network security. And the third is the security due to the various human interfaces, such as the social network sites and so on. So, as we mentioned right in the first class, that when we talk about information security and when we talk about an attacker who wants to actually target your system, the most critical it's the attacker has uh, multiple choices to he can actually target. He can actually use. So, um, what the attacker actually requires is just one weak link in your entire system, uh, and he could exploit that weak link to gain access or to do something malicious in your system. So this weak link could be either through the network connectivity, or it could be in your hardware or operating system or the various applications, or it could also be through the users using your computer system. For example, the user who is uh, say browsing a social network website is actually forced to click on a link or install some particular applications in that particular in the program. So all of this could be potential threats, and therefore has to be considered very seriously when evaluating a system for its resistance to attacks. So what is the extent of Metasploit attack? Um, there are two questions. One is on Metasploit. So Metasploit is essentially a tool that could help you to launch various attacks. It typically has techniques where you could scan the network. It could actually find out vulnerable locations, vulnerable computers, or vulnerable services in those computers, and it will also be able to identify what are the vulnerabilities, and it will also give you a payload um, for mounting an attack using that vulnerability. Now, there are a lot of tools like Metasploit out there, but what you do not get from, or what you do not, while Metasploit makes things very easy for you, what it actually hides is the difficulty of actually creating an attack. So this particular course, on the other hand, we have gone to the grassroots level and tried to identify essentially what Metasploit is doing internally, right? In a lot of cases. So we actually looked at how payloads would be written, how vulnerabilities could be exploited, and so on. So all of these things, Metasploit has scripts which can do it automatically for you. Okay. Sarang uh, has a question. So what exactly is ethical hacking? Okay. So yeah, that's an interesting question. So uh, yeah, so ethical hacking could be anything. It could be startup of a project, but more importantly, uh, ethical hacking is used by companies um, to actually protect their infrastructure, their IT infrastructure. So what they do is they hire offensive uh, like hackers who then try to actually evaluate the security of their system by trying to using things like penetration or trying to actually hack into systems with the end objective that the company itself uh, evolves better, strong security policies to protect their entire network. So another interesting and very relevant question is from Nitin Kumar Kashyap, who asks about cloud computing and about the security of cloud computing. Uh, so, uh, so Nitin, like as we mentioned earlier, the more uh, things you actually try to open up, um, the more are your vulnerabilities. So, for example, if I am running a software or I am having very sensitive data and I store that data in my laptop, it would be relatively safer compared to actually moving it onto a cloud. So first of all, when it is on my laptop, what I am guaranteed is that that laptop is owned by me. I'll be carrying it in my bag all the time, and therefore my data is safe as long as it is the laptop is with me. On the other hand, if I have to secure that same data, but I want to move it into a cloud, it opens up a lot of additional vulnerabilities. First of all, cloud providers like Amazon, the AWS and Azure from uh, Microsoft, they are essentially third parties. So, soon as I put sensitive data on the cloud, inherently I am trusting the third parties, the cloud service providers. So I am trusting Amazon. I'm trusting all other companies which are actually providing this cloud infrastructure. The second aspect, which also opens up vulnerabilities, is the fact that um, when the main reason people are offering clouds is that they have infrastructure which is shared by multiple parties. So, for example, I would be sharing my computing resources with somebody else who may be totally untrusted. And whenever there is such sharing, as we see in the seventh week in particular, whenever there is sharing of computing resources, there is a potential that there is a loss of information, or there is a leakage of information from one person to another. So one user of the cloud to another user. So yeah, so if I have to compare storing your sensitive data on your laptop versus storing your sensitive data on your cloud, on the cloud, so definitely the cloud is going to have more vulnerabilities and it is going to be less safe, just because of the fact that there are so many other people involved in a cloud computing environment. So this being said, cloud computers have a lot of advantages, especially for small companies, small and medium-sized companies. It brings down the costs considerably. So small companies, for example, who would like to use cloud computing services to actually offload a lot of their computing. And in fact, there are now many companies which are actually using the cloud. Um, to and reducing costs, and they don't have to have too many system administrators. They don't have to keep updating their computing hardware and so on, and that's the big advantage. So as we've been going on reiterating in this session, security is always a compromise between couple of things. So with cloud computing, it is your trading of security with cost of actually running your establishment or running a particular company. So previously, we had seen that security is traded off with say performance or the features that are provided. Like for example, with the bank is the safest if it does not have any credit card or debit card or any banking website. But also, when you have such features, you are having more security vulnerabilities. Uh, okay, so another question from Yash Patel. Is there any way to detect and stop hidden rootkit codes in a PC? So, yeah, this is a very good question, and it actually opens up, it also points to the fact that detecting rootkits are extremely difficult. So, there are antivirus software which can actually do it, but no antivirus software is can guarantee you 100% results. Um, you can always write new rootkits which can bypass these antivirus. Does C programming help some way in hacking? Which is the most useful programming language for hackers? Yeah, so yeah, so let me just uh, tell you the benefit and the disadvantages of C programs. Uh, so there are, of course, C is kind of the most popular programming language with respect to system software. For the last 40 years or so, now C and C++ have been the default thing whenever you want to actually write an operating system or write any system level programs. And therefore, uh, although there are a huge number of security vulnerabilities that will crop up in your code due to a C program, still C is quite largely used. Okay, and so how is it useful for hacking? I don't think so. C is from a hacker perspective. So there are two aspects. So typically, a hacker would use a scripting language like Python or Perl, and he would target a, he maybe target a targeted victim application which may be written in C or C++. So therefore, if you're a hacker and if you're a good hacker, what is required is that you actually um, uh, have a very thorough understanding of C and C++. So you would want to uh, you would want to exploit or create exploits such as the ones that we have seen in the demonstrations on heap exploits and buffer overflows and so on. And as you would have noticed over there, that you need a very deep understanding of how C programs are actually managed, how operating systems are built, and so on. So, what I would say, answer to this question is that while a hacker does not directly program in C, he needs a very thorough understanding of C and C++ to actually build exploits. So so another interesting question. So how can an entrepreneur get an opportunity in information security? What is the best way to utilize IT security knowledge with the Okay, so there are, like I said, there are like huge amounts of opportunities in information security. Especially our country has like a deficit of security professionals, and so how could you actually build uh, have a startup on information security? So yeah, so I don't think I can answer that right now because there is like innumerable number of options. So for example, you could just create a just to connect it to the previous question that we've answered, you could just create a company or startup which just focuses on cloud computing security, or on the other hand, you could have something which is totally opposite, which looks at say uh, hardware security. So depending on your skill set, you could have like a zillion different opportunities. Yeah. So again from Nitin, who seems to be very interested in cloud computing. So he says that when our data stored is in the cloud of an outside country region, uh, or and they have different rules of their region to access our data. So how can I say that my data is secure? So as I again reiterating the same answer, uh, if you put your data on the cloud, your data is not secure. It's just that you are trusting the uh, your your cloud provider, and you're first of all trusting that your cloud provider does not actually take your data and expose it to somebody else. And like you actually rightly said, if your data happens to be stored in a country which permits, let's say, the government to look at the data which is stored, so that could also lead to different, yeah, so that would also lead to your data getting lost or stolen or getting hacked. Um, so therefore, yeah, cloud uh, computing may not be your best bet if you want like security. Okay, so Nitin is asking another question. So this time it's on the attacks and exploits. So he says that um, nothing is 100% secure. So how can we secure ourselves with the latest new type of attacks and exploits? So this is a very interesting question because in order you cannot actually, while it's very difficult to foolproof your system and make it 100% secure. Although it's been done in the past, it's very difficult to implement it in practice in a very large scale. Um, if you want to remain secure, the best way is to ensure that Your security patches, your system is always up to date with the security patches. Uh, Ensure that, yeah, so that could be one of the main things. Do not click or reply to any emails or web links which seem incorrect. So I would say these are the main things that you should follow. Uh, yeah. So another question from Nitin is about the Tor browsing. So Tor, just to make it aware to others, Tor is provides you uh, uh, like it, you're able to hide the routing. So it's very difficult. Provides an onion routing kind of mechanism where it is um, not difficult, where it is difficult to trace back the origin of a particular uh, TCP packet or a TCP or UDP packet. Now, yeah, hackers do use stored networks quite often, so that it is difficult, although not impossible, to trace back the origin of a particular attack. So, for example, hacker sitting in a particular location, say X, would and wants to attack a computer at a location Y. So he would use Tor so that when the attack actually uh, occurs and the forensics actually try to trace back as the cause for the attack, it would be very difficult to actually trace back the cause to that location X. So again, there are. So his question in particular was for what are the ways to actually trace back uh, a hacker who uses a Tor browser. So one thing to actually note over here that yeah, tracing back Tor is a it's quite a difficult task. There's been a lot of research papers in the recent past to actually like break the security of Tor. So one thing which was possible and which I am aware of personally, though I have not actually worked in this area, is by use of timing mechanisms or side channels to identify delays in routing, which can give you hints about the origin of particular packets. So I request you to actually search up on Google as to other techniques which can break the anonymity that Tor guarantees. Okay, so Krishnendu Das asks a question. So, how do we know that an application contains a malware or an application? How do you distinguish an application to be benign or malware? Because sometimes we see that there is software which may contain spyware, right? So yeah, so if you're given an application, it's not very easy to determine whether there is a malware present in that particular application. So of course, this is what the antivirus softwares actually excel in. So they've been able to actually look for specific signatures of malwares, either statically, that is on the binary file of your application. They look for specific signatures which are or specific patterns in that binary file, which can link it, and they look into they which and they try to compare it with a database of different malware signatures, and they're able to actually identify if they're able to identify that some pattern within the binary file matches that in their malware database, then they could flag that particular file as saying containing malware. So this was done. Um, yeah, this was done maybe about a decade back. Since then, malware has become quite intelligent, so they've been able to very successfully hide themselves uh, in a way such that antivirus cannot detect them from their static executables. And therefore, now antivirus actually looks at the dynamic behavior. That is, whenever an application runs, the pattern or the execution characteristics of that particular application is then matched to different malware signatures again, the runtime characteristics of malwares, to identify if a malware is actually existing. So one thing, for example, which a lot of antivirus actually do, is to actually track what are the files opened, uh, what system calls are invoked, the pattern in which the system calls are invoked, the what HTTP or sockets are opened, or what network sockets are opened, and so on. So these characteristics, which are known at runtime by the antivirus software, is then used to detect whether a particular application or whether a process in execution uh, is doing something malicious. Now, there could be also flaws. There could be false positives or false negatives. By false positives, we mean that a particular benign application, which does not have a malware, gets flagged as a malware just because there are certain characteristics which certain way it executes, which the antivirus software thinks that it behaves like a malware. In the same way, if you there could be some very smart hackers who could write malware and inject that malware into programs so that it can it does not get detected by antivirus. So this becomes a false negative. So so Nitin asks again, what are the best practical practices we use and implement to secure our node or PC when we work online? Yeah, so as long as you're connected, if you're talking about a user perspective and not into the design perspective, then you ensure that all the patches are uh, made uh, in your system. All the security patches are installed, and also ensure that you do not download and click on links that you do not trust. Also ensure that all signatures that you obtain are in fact valid and trusted by some certifying authority. Okay. Okay, what aspects of security were covered during the first four parts of the series? Is there a part six? So as of now, we don't plan to have a part six, but uh, I think you can look out for it, not this year, but perhaps in the future years. Yash Patil asks, Yash Patil asked a question, but I don't seem to understand what that question is. So he asked about who can uh, Linux OS more secure than Microsoft. Can you please? I don't understand that question. Oh, okay. So if I understand Yash's question properly, so he says that uh, which is more secure, Linux or Microsoft? So one thing, what I would say is that both of these operating systems are extremely large operating systems. So both have uh, billions of lines of code present in them, and like we've seen, it's very easy to have these bugs and vulnerabilities present in such kind of codes. So both Linux as well as Microsoft, I would say, are equally vulnerable. However, there are certain characteristics of Linux uh, which make it a bit more safer to use. The first thing is that Linux is open source, so therefore you have a very large community which is continuously improving the Linux kernel. So the patches, security patches are obtained are at a much faster rate, just because there are more people involved in the Linux community. The second aspect is that when you talk about malware in particular, since a greater percentage of systems are running Windows, so malware creators or people who actually develop malware would rather focus or spend more effort trying to break into Windows system just because of the fact that there are more Windows systems available worldwide compared to Linux systems. So therefore, you tend to see more malware written for Windows rather than Linux. So a growing threat also, just to add on to that point, is malware written for Android systems. So Android, as you know, is used in mobile phones, and as you see, the growth of mobile phones is escalating very quickly in the past few years, especially the smartphones. And therefore, hackers are now targeting Android or writing Android malware just because there's a larger volume of targets or which are available. So how can we detect virus spyware except antivirus? Except by so Krishnendu asked again a question whether we can detect virus spyware without using antivirus. Yeah, so that is pretty difficult to do because as we mentioned, viruses are these days are extremely sophisticated. Uh, it's also possible that antivirus software themselves do not work like software which is specializing in detecting such viruses may not themselves be able to find it. Therefore, without using an antivirus, I don't see any other way right now. Okay. A question from Zishan Akhtar. The course mostly covers vulnerabilities in the C language. How does this apply to other programming languages and compilers? So this is a very, very interesting question. So the reason that we focused on C is that we are looking at uh, system level vulnerabilities. So we are looking at vulnerabilities in the operating system, system software, uh, and the large amounts of software that is actually coded in C. So this makes this makes things yeah. So C as such, while it is an extremely flexible language, it permits you to do a lot of permits you to actually work very close to the hardware. Nevertheless, C is prone to such security vulnerabilities like the ones we've seen in this particular uh, course. Now, you could always use other programming languages like Java or newer programming languages. So like Java is a well-known thing, which can give you much more secure environments to work. However, you see that Java is not always the solution for all applications. For example, if you want to write a new operating system, it's possibly it's not easy or maybe not even possible for you to do it with Java. So yeah, you with other programming languages like Java, it is you will not have these vulnerabilities. That are there may be some new or different set of vulnerabilities associated with these programming languages, Java, JavaScript, and so on. But that is beyond the scope of this particular course. Now, this being said, if you want to write system software, there are some new programming languages which are being developed. The most popular of them these days are Rust and Go. So these languages permit you. In fact, have been some research work where you write or develop operating systems in Rust as well as Go. So these programming languages are much more secure than C and C++, um, and provides you all the security that Java offers uh, with less with not much performance overheads. This being said, uh, it's not very easy to change or eliminate C and C++ programs, right? So C and C++ has been the default programming language for the last 40 years or so, especially when you want to write something which is very close to the hardware. Uh, Most of the embedded systems these days, most of the IoT systems would be programmed in C or C++, and replacing all of them is kind of impossible. So unless C is here to stay, and with C we have these huge amounts of vulnerabilities which are leading to all of these problems. Uh, so yeah, I am not an expert with cross-site scripting. This is a question which is asked by Nitin Markasha. So I will not be able to answer this particular question. Are there any other questions? Yeah. It looks like we have tried to answer most of your questions. One thing this course try to do is it try to expose you to the internals of C. We try to actually look at vulnerabilities that are caused in C and C and C++. Most of these vulnerabilities, at least the demonstrations that we have done, are for Intel platforms, while such similar kind of vulnerabilities are available in all of the other platforms like ARM or things like that. Okay, the idea is that if you want to be an excellent hacker or you want to actually work in this domain of security, it's not just the and this is the point which I want to make. It's not just the tools or techniques or tools of the various uh, tools like Metasploit or things like what you actually brought up. So it's not just the tools that you need to actually study and the various options and uh, features that are available in these tools. It is to become an excellent security engineer. It is very much uh, important that you understand what is happening internally, understand what is creating the flaws, um, understand how to actually prevent these flaws, how to write programs such that are not just working fine, working correctly, and giving you an output very quickly, but also learn to write programs which have high, uh, which are also secure. So these are some of the things which I want to actually highlight in this particular course. So also, this course was giving you a very broad aspect of the various uh, themes in system security. So we looked at programming vulnerabilities. We looked at how to design huge applications like web servers, which are less prone to, which are more secure. And we also looked at hardware level vulnerabilities, or we will look at hardware level vulnerabilities like cache timing attacks, um, hardware features which can enhance security like puffs. And also in the eighth week, we'll be looking at more in detail at hardware hardware trojans, which is a very popular, which very hot topic or very difficult to actually prevent. Uh, okay, Okay, so Nitin asks a question. So, suppose somebody is actually interested in taking become a professional in information security. So, what is the direction? So, one thing for sure is that, and one thing what seems to be recognized in the industry is the um, various courses, information security examinations, which you can possibly take, and get certified first of all that you are an information security expert. So there are. I'm not going to which uh, examination is better and so on, but that's for you to actually find out. So is there? So Moinuddin Mohammad Faizan asks, is there any particular resource for learning more binary exploitations, more about which is not covered in this course? Yeah, so like I mentioned, there are a lot of if you've understood the at least the first four topics, the first 4 weeks in this course, you would not find, and you've been able to actually follow the demonstrations, and there are some certain challenges which are available on the Bitbucket website. If you're able to solve those challenges, then it will not be very difficult for you to actually adapt to the other vulnerabilities, although we try to cover most of them, there are still quite a few which are present. It'd be very easy for you to actually adapt to those, or to understand those vulnerabilities. So, what I would suggest is that once you've gone through this particular course and you're still interested in binary exploitation, and if you feel that you have understood these things well, you could always send me an email and we could talk about it more over email or. Okay. So yeah, we can wind up now. So if you still have any queries, I welcome you to actually send those queries on the forum, and we can actually get back to you on the answers for that. And so anytime um, we could from for asking the question. No time is bad to ask a question. I hope you'll actually enjoy the remaining part of the course. So we've still got 2 more weeks to go before the final uh, session, the final week, and then the course examination. So I wish you all the best and happy hacking. Thank you.